So hi, welcome to ROBOTIS Talks. This is a robotics talk show featuring the members of our team here at ROBOTIS. We're trying to highlight the cool or interesting things that we've heard about or seen in the last couple of weeks, being active members of the STEM community, as well as talking to some interesting people in the robotics community. Allow me to introduce myself. I'm Gavin Bleestrap. I'm the technical specialist and STEM consultant here at ROBOTIS. I'm joined today by Andrew. He's another technical specialist and STEM consultant here at ROBOTIS. So, hi, Andrew.
Hi there.
And we're joined today as a guest interviewer with Michael Overstreet, who is a 3D printer enthusiast. 3D printer enthusiast, as well as an extremely active member in the STEM community. He creates a lot of videos with educational robotics, alongside with videos about our products. So hi, welcome, Michael.
Hello.
And as our guest today, we're joined by Anouk Wipprecht. I can't say your last name as I was getting to it.
Yeah.
Can you say it for me, Anouk? I'm sorry.
Anouk Wipprecht.
She's a Dutch fashion designer based out of Miami, Florida. She's not your typical designer. She uses a lot of technology incorporated into the clothing and hopes to gain insight to deeper levels of self-expression using technology. You might have seen her spider dress that reacts to the presence of people in your personal space and takes an aggressive posture. She's also been working a lot on robotics that help to dive deeper into people's minds, as well as processes in which we learn. So welcome to the show, Anouk.
Hey, everybody. Thank you.
So yeah, I think we're going to just jump right straight into the questions for you, Anouk. I'm really interested in the kind of fashion design that you've been doing using technologies. So I was curious about what made you want to pursue this form of high fashion, where you actually incorporate a lot of sensors, servos, and logic into your designs.
Yeah, I think for me personally, when I was really young, I was always very observing people and things. And I noticed that people were expressing themselves through their garments and what they wore. So when I was 14 years old, I started my study. That was fashion design, so couture and tailoring. So I got really good at constructing garments. And I thought that was what I wanted to do. But at one point, I started to notice that the designs that I was making were analog. They were not digital, or they were not reactive. And when I was 17 years old, I got into robotics. And for me, the robots were the heartbeats and the brains that I wanted my garments to be. So I started to connect these pieces of electronics, and it was the beginning of 2000s. Especially with big computers, which was not really handy or sexy, because it might look nice from the front, but you turned around and there was this big computer on the back of my design, So in the half of 2000, the guys from Arduino came in, and I read it in a paper, and I got really interested in that because it allowed me to work with a small computer board instead of a big one, So I've seen technology grow from being pretty big that we had to work with to the small little parts that we can use now.
Yeah, nice. I mean, I think back in the 2000s, the smallest computing stuff you could get was like an FPGA, which required you to have a lot more knowledge to program than a lot of the stuff that we have today, especially from Arduino and from Raspberry Pi. Much more user-friendly than having to code every single block to do exactly what you want it to do.
Yeah. With a lot of pros around it, you might want to do a really simple thing in a really complicated way, so yeah.
Yes. Things always appear simple when you're writing it down, saying well, this is what I have to do, and then this is how it has to go through, and then you sit down and you try and write your code, and you're saying, well, I'm just bad. I'm not good at this. I'm not good at this. You started robotics when you were 17. Do you remember what you started with?
I started with using servo motors, I don't know exactly what it was, 9G, really small ones, which allowed me sometimes not really to do the things that I wanted to do. Then into really big servos that were too bulky. So that was actually cool, because that is how I got to you very later on. in 2012, I got at Specular Theory. It's a big special effects studio in Burbanks, and you have a guy there. His name is Mark Setraticon. He's a roboticist, and he's using your ROBOTIS motors. And I saw that, and I was like, "Hey, Mark, what is that?" You know, because he was like just talking about you guys like you were gods, you know. And that's actually how later on I got to use your XL 320s through Mark, because he recommended me to look into that. So of course he's using you guys need to look him up if you don't know him.
Oh yeah.
You need to look up the studio, and those guys are really cool, Mike and Mark. So that's how I got to use ROBOTIS, and I think that was like 2012, 2013. Before that, I was using a lot of like hobby motors. They might not have been so strong or so smart, sort of.
Got it. Yeah, that's hilarious, because I've actually talked to Mark Satrakian before. Like he's somebody that we talked to. I've only been at ROBOTIS for like, I don't know, 6-8 months, and I've had multiple conversations with Mark. So it's always fun when I hear like other people's names being dropped who I know inside of the community. That's super fun.
Yeah, Mark and Mike are just incredible. Like the stuff that they do with the studio. I've been there multiple times, and it's always like like monsters and mechanics and robotics, and it's super cool. Yeah,
it's interesting to hear that you made such a, because going from a hobby servo to a Dynamixel was actually like a pretty big shift in like the amount of technical like information that you're getting as feedback and that you have to send to the servo. Was there a learning curve, or do you have any difficulty learning how to use ROBOTIS servos?
Yeah, in the beginning, I must say, like some of the things, everything was in Korean. So the first boards were in Korean, so I had a hard time with that. So I've been emailing your Korean vision like a lot of times back and forth. Actually, I started then connecting it over Teensy by Paul Stofregen. He had there was a tutorial out from people in, I think, Australia or something like that, and I found that online. And actually, not working with the board for the first time because it was a little bit too difficult. I did it over Teensy, and I connected then the Teensys to the XL 320s. And later on, when I was working at Intel in 2014, we connected it to the Intel Edison. So so from I found a little bit of a way to work around that in the beginning, sort of. But
got it.
There's multiple ways to roam.
I wanted to ask you more about your prototyping, and I think Michael probably would be a better person to ask these questions, because he does a lot of 3D printing as well as being involved in the maker community. Mm-hmm. So if you have any questions that you'd like to ask Michael.
Sure. So I'm just curious about your design process. I mean, I know it's going to be a really broad question. So whatever, comes to your mind, or kind of walk us through your design process, how you go from nothing to the spider dress. I think I've seen lately was like a video game for a model. You designed
Yeah, correct. I think it always depends on, is it the technology that I want to work with first? Then I would dive into the electronic side, what it can do and what it cannot do. I like to test with that sort of, that like informs me what steps I can take. Then I start to work on the design part. For example, the spider dress. If you look up Spider Dress Black, that was actually the first version in 2010, which was a 2D version. It was laser cut. I laser cutted it, embedded the servos in there. There were over 200 screws in that version. So there was a lot of screws. And at Intel later on, I got the opportunity to work it out again and to create from that spider dress that was laser cutted before a 3D printed version, So sometimes I work with cardboard, start to work out the shape of things, start to like pull it and to see if the mechanics on the shoulders, how I think of it or how it looks on sketch. It might not conform to the body as you want. So you can either work that out in 3D. Before 3D, I was doing a lot out of like cardboard, out of like just materials that I had laying around just to fit the shape. And then I started to work with embedding the sensors, looking at the weight. What is the weight? How does it conform around the body? And then deep diving more into the design factors, into like sculpting, modeling, kind kind of stuff. And that is where either laser cut, 3D print, like whatever kind of machining I want to use, CNC. And later on comes in as a solution almost, you know, to make it lighter, to make it depending on really what it is, you know, to make a certain materiality so light can come through. So there's always different ways that I approach it. The spider dress I might approach differently than when I create an dress that might be my smoke dress, you know. Then it's all about the smoke and how to push the smoke in a nice way out of the 3D print, you know. So there's always, I think, a design challenge, and that's kind of my engineering mind, what I like, how to solve that, and how to solve that in a very elegant way, and that is where design comes in almost.
Do a lot of your designs driven by like, this is what I'd like to learn next? Because there's definitely different aspects to your dresses that I've seen. Like as somebody that's studying engineering, like a lot of the progression that I've seen in your dresses are a lot of the directions that I've gone, where it was like, you know, mechanics to fluid dynamics to data analysis and games. Like, do you think that a lot of it is driven by your own interest in learning the engineering process or engineering tools?
I think it really depends, because I work a lot with brands. So sometimes it's guided by what the brand wants me to do. The current project that you talked about, we worked with a dancer with a prosthetic arm for the game Just Dance for Ubisoft, and they wanted me to work with a lot of strange colors. So there's the client pushing me into a certain direction, you know. Which I normally would not have gone. It was for the use of the green screen. So there were a lot of complementary colors versus colors that we could not really use, and textures and all of that stuff. So sometimes it's brought up by the client. Sometimes it's brought up by the piece of electronics that I need to work with. Or sometimes people give me a carte blanche. I can do whatever I want. So then I always have a whole file with things that I still want to work on. You know, if I'm working on a project, I start to write it down. Like, okay, not for now, because you need to, otherwise I get too distracted, you know. You're like, okay, this is my red line, I need to focus. And then I like to write down, like, okay, these are options for another time in terms of programming behaviors, in terms of design solutions, in terms of like whatever that can be, sort of, you know. So it always depends on what angle it comes from, if it's from a client or what is the main thing that we're trying to solve or tackle here almost.
Go ahead, Michael, I'm sorry.
So it's interesting to listen to you talk, because I think I've seen previous talks you've done on how you design stuff. So, because for me, how I design stuff is I kind of visualize it in my head, and then I try to use like Autodesk 360 or Fusion 360 or whatever to design it, and then I have a printer and Prusa printer and other printers. And then what I do is, once I make my 3D design, then I print the part out and look at it and see how it fits. And then I do iterations, you know, slowly evolve. Sounds like you do more of a prototyping with like the cardboard. I don't know if you've changed since you first started designing dresses and stuff, or interactive clothing. But I do the 3D design, you know, see in my head 3D design, 3D print it out, and that's my process. Your process seems to be more maybe more like
Yeah, I think like sometimes I work the same way as you, in if I have a clear idea, sort of. There's one variable, and the variable is the body, and the body has a unique ways of moving and just like sort of your silhouettes and all of that stuff. So sometimes I go into design from here to there, sort of. Sometimes I use more of a mock-up kind of or prototype kind of scenario. Which especially I did more in 2000, sort of, you know, in where I'm just trying to use materials that I have at hand, laying in my studio, and try to produce that. Behind here, I'm now at my home, and I have a home and a studio, but in my home, behind me, I have a laser cutter, a BMO from Flux, and I have a Dremel, Digilab, 3D printer. I have my soldering station and a sewing machine. So whenever I have an idea in the evening, I don't have to go all the way to my studio. But these I use, for example, here, if I have just an idea, I would print it out in small. But if you want to print a whole dress out, you know, that's harder. Like I use a surface like Shapeways and all of that stuff. So so I do like, yeah, intonate on design. Like I can shoot it off, just I can make it in a small form, or just a sample or something like that. I can like print things out, especially for if I need to make something fit or something like that. You don't want to wait on Shapeways for like 2 weeks, you know. You want to have like a machine, like a cheaper machine in your house almost to do that with. I think like a lot of like, yeah, things you can try out, like, yeah, if you're creating a design. But sometimes if you position it on the body, either you want to have like a scan of the body, but then you still don't know how a person moves almost, you know, versus like you have an yeah, just trying it out on yourself. So I have mannequins, I have dolls, I have 3D, I have my figurines in 3D as well, and all of that stuff. So it always depends on my approach and my, yeah, level of creativity versus more engineering. Okay, this is what I'm gonna do, this is how I'm gonna do it, sort of. So I think I like to play around with it, sort of, you know. Sometimes I'm more in a creative mood, and I like to just work with flows and more. That's what I learned from couture, you know. In couture, you do your trials and all of that stuff on the doll, and there's something for me to that physicality of really working with your medium, whatever that can be. It's a fabric, it's a leather, it's like, yeah, cardboard, what later can be laser cutted, what later can be 3D printed, whatever that ends up being, sort of, you know. And then also I'm using a lot of like, yeah, different tools from like, yeah, CNC to laser cut to 3D printers. Sometimes I work in silicone, in molding, in sculpting, in airplane epoxies and all of that stuff. So it really depends on the medium that I want to use almost.
Okay, cool.
Yeah.
So the
Cool.
a lot of the cosplayers that I've met at maker fairs and other events, they actually use a they call it thermoplastic, which is basically a sheet.
Yeah.
The sheet, they cut out the form, and then they heat it and they form it to their bodies.
Yeah.
They
They use thermoplastics, or they use Worbla or something. It's foamy kind of stuff. Yeah, you see that a lot if they make like shields and all of that stuff. Like if you're doing things with architectural shapes and a lot of spacing and geometries that are complicated, it's a little bit harder to do that because you need to work with perforated things, which mostly are better in like laser cut, or if it's volumetric, it's better in 3D, of course. You know, if you look at yeah, more architectural kind of designs and geometry, sort of. But yeah, definitely. I mean, that's yeah, that's a possibility. It just really depends on the aesthetics that you want in the end, I guess. And the other thing is, like, I will also use my design for housing the electronics and the cables and the wires and the PCBs and all of that stuff, of course, as well.
So when you were designing the arm, did you scan the model to get all the dimensions? How did you get the correct dimensions for the arm extension?
Yes, well, the funny thing is that the dancer was in Brussels, the company was in Paris, and I was in Florida. So what I did was I asked around to my Facebook, like, hey, is there anybody in Brussels that can scan in a dancer that I work with, her arm? And we sent her to them. They sent the yeah, the files to me and the prosthetics company, Michael Tittel, I was working there with. And yeah, in that way, Michael could make the liner and the socket, and in the same time I was, yeah, starting to make design the arm and the plexiglass parts and the rest of the outfit and all of that stuff. So based on that scan, we had the exact the shape of her. It's called the residual limb, so her leftover arm part, sort of, you know, that the liner could mount over. Then the socket had a vacuum pump, and on that is the spike shape.
Very cool.
So, and
like,
I think I have that here somewhere.
Okay, cool.
I have here some.
There's actually a nonprofit. There you go. There's actually a nonprofit website that you can basically take a tape measure and measure the arm or whatever you're trying to replace, and then you plug this all into their little calculator.
Yeah.
And then you can send that out to be printed like a Shapeways or I Materialize. So yeah, that's very cool.
Yeah, I'm always amazed that with prosthetics, how they still like use really old techniques. Sort of that is what me and Osu were. That was actually the first company really that works with more like a 3D kind. Normally you measure every like little millimeter of the arm, and then what you say that goes into your that's being calculated. But like, yeah, scan is much easier to work with because you just have all the correct shapes almost. So
You get
these
all the
are
contour.
yeah, this was some of the shaping. This was printed on like normal like a normal 3D printer, and then this is the final one. It was this is a purple version, but that's in SLS print. So I mean, this was a nice one too. They did that. Osur Michael did this one just for the shape of it. I could not do it on my Dremel. I think he has a Delta printer there, and then basically it goes into SLS, which you can see here. And then what I do is I use the SLS, and I use car paint, so you get a really nice gloss. So it's sanded and then painted, and then here you can see some of the plexiglass parts in there. Okay. So so that's mostly the process to do at home. As far as you can do on your own printers, and then as soon as you have your security, like you feel secure about your design, then that at that moment I'm going to send it off to Shapeways, and often it's one or twice, you make some adjustments, and then you have the final one that you then start to normally paint, embed, like solder, program, and then it goes out in the world, sort of.
Very cool.
Yeah. I wanted to ask you more about, like, how you felt about the materials and methods that you use to design dresses currently. And it's kind of one of those things that I feel like you probably get asked a lot. But do you ever feel like you're limited by the materials or the kind of things that you have to use to get an idea to work? You're saying that, back when you first started, you didn't want to see somebody with a backpack on and having their computer inside of that. Do you still feel that way? Or do you feel like technology has advanced to the point where whatever idea that you would want to pursue, you can pursue it fairly easily?
I think so, yes. Though I do use a lot of like hard materials. I'm using a lot of SLS, PA12, PA11. So those are really hard materials, whether garments you want to have as soft as possible. But mostly I like to protect my electronics, especially when you're working with robotics. You want to have as less friction as you can. So mostly I work with a little bit more exoskeleton style, like more Gigeresque almost, in order to protect the electronics, because that's always important for me, especially these pieces travel. I want, if it goes to a museum or showcase, I want it to be not breaking down in any way. So some of the more recent developments in like soft robotics into 3D printing materials that are more softer, I mean, that's always cool, but there's always a level that where do you want to protect electronics versus where do you want to work with the softer kind of elegant materials there, sort of. So that's a little bit the engineering mind versus sort of the fashion mind in that case.
Have you I've seen this lately, well, not lately, people did it around a year or so, where they actually have fabric material and they 3D print on top of that. So, and that gives them more flexibility, because it's not just a sheet of plastic. It's got some kind of fabric, and the parts are 3D printed on top.
Yeah, like scale structures and hexagon shapes, sort of, in order for the movement to come through. That's nice. Getting that to robotics is a little bit harder because that's more around, but it definitely conforms like nicely to the body when it's printed on fabrics. There's a lot of people that are doing things with also using materials like leathers and all of that stuff. So that's always nice.
Yeah, I wanted to say that I actually saw something very similar to the printing on fabric, but instead it was a project where they had been, they created a print with, kind of a scale structure. And then midway through the print, they actually installed the rings that were then enclosed that whole, So it was kind of like this
Shori.
chainmail.
I think his name is Shori Design.
Yes.
He's always showing his things on maker fairs and all of that stuff. Yeah, he got really good at seeing what people were doing with printing on fabrics, and then having more the engineering mindset of how to make that more sort of mechanically better. Sort of, yeah. I love his things. I think he posts it on social media a lot whenever he does new things with that.
Oh, absolutely. And
Yeah.
I think it was it's just an interesting point to, mention the materials, because I had kind of wanted to ask if you had ever used any of the, I'm not sure if you're aware of any of the like flexible Arduino based boards that some companies like SparkFun are making. I believe, they have a line of boards called Pedal, where it's actually a flexible Arduino. I was curious if you had ever considered using things like that, but it sounds like you go with more the traditional electronics and then try to
no, it depends. I use the more flexible boards. It really depends on what I'm making, sort of, if it's a more robotic design versus a more like body following design. It's mostly my own interest to make things harder sometimes,
Okay.
But I think there's a lot of like interesting, like flexible solutions that can be, really seamlessly integrated in a fabric and all of that stuff, which is really interesting. Or also more people that think of like boards that have maybe not a square shape, and a round shape, or I use a lot of more flexible wiring and all of that stuff, so it conforms more to the body. But that brings up another, I think like more of that is always needed in this field. Also, if you talk about batteries, they're pretty big and clunky, sort of, when I think the field of batteries would be also more, for example, flexible or like different shapes. Like the body has a lot of organic and round shapes, so we want to have more boards and PCBs and all of that stuff. So often I end up designing the PCBs myself in more of an curved shape, sort of curved shape, or multiple boards that are connected in a certain way, sort of, because the body really needs like round shapes almost.
Yeah, that makes a lot of sense. So that's actually just interesting to hear from me, because I think that's something that a lot of people don't think about, and just how so many electronics, we're just used to them being square.
Yeah. Well, one of the first after Arduino, Lee Buckley, she came out with the LilyPad Arduino, which was the round one. You could connect with the conductive thread, and that was pretty early on, So I thought it was always a cool thing from her to make that a round board. Was like more than 10 years ago. Yeah.
I think that and the NeoPixel were like both, like those were my first introduction to round PCBs and round electronic design. When I saw them, I was like, wow, that's crazy to see. Is Michael holding up?
Yeah.
Yeah,
nice.
This is one of the earlier books that came out from Make on wearables and electronics.
Yeah.
I forget where I got this one. But yeah. There's all kinds of really cool stuff happening in the last few years.
Yeah.
So this is kind of like a good segue. How do you start adding robotics to your stuff?
My work is mostly based on research. I'm researching things. I'm researching if and when you put technology on the body, what does it do? How does it behave? How can it interact? So my background is interaction design, right? So that's all about how things interact and react. So that is basically where I come from. I come from fashion design, got into interaction design through the gaming, sort of the gaming school in the Netherlands, and art school. That is really my fascination. If and when you put technology on the body, what does it do? And then you have fashion, which is really expressive, but maybe what we wear now is analog. So how can you embed electronics in your garments, and how can you create behaviors? And if you walk up to my spider dress, it measures up to 25 feet. That you use ultrasonic rangefinders. And it's reacting in a different way than, for example, my smoke dress. So the spider dress, you walk into the personal space and it's really attacking, like defending your personal space. Whether I have a smoke dress and it has sensors, it measures how many people are in the direct surroundings of this dress, and the more smoke comes out. So that is about the amount of people, and that's almost about the emotion of shyness, So I work a lot with like emotion in my designs, and then what does it do? So if you look at a spider dress, it's a really sharp V style neck shape, neck piece. and when you interact with it, it's airy, it's attacking you, you know, so it's a very defensive design. Whether the smoke dress is very elegant and it's almost, yeah, when you walk up to it, it's not super creepy, you know, in that way, it's very elegant. So I think my design is all about, these things, whatever is happening on the body, that can be smoke, that can be colors, that can be, I just love a lot of like mechanic things and robotic stuff, you know, because you can create a lot of behavior with it. Like the spider legs, you can create, you have multiple degree of freedom, right? So the more degree of freedom you have from a robotics point of view, the more you can do with it, the more you can animate it, the more you can create behaviors. With an LED, you might have colors, you might have blinks, but that's it, sort of, you know. So for me, that's an interesting medium, but I would not never use it as my alpha medium. My alpha would be in the spider dress, the mechanics, or the smoke, you know. So I always look at that model of where how everything can be woven together, you know, because if you have a design that you walk up to and it reacts too slow, or it just gives a weird sound, you're like, okay, what's going on? So everything in the end needs to work out, how it moves on the body, what it does, how you interact with it, what the robotics or whatever it is, sort of the interaction is doing. So my main thing is basically interaction design, and then I have a lot of like researches, like sort of almost research in there. And every time I create a design for myself or for a client, I try to push this new way of looking at a certain thing by working it out and trying it out in an audience, and see what kind of feedback I get from that, sort of, you know. So it's almost like little case studies that I do, I would say. Then just having something cool to show off. For me, it's really, okay, what does it do, you know? And what I predict it to do, does it do that in reality, if it goes out into an audience, for example? And I think then for me, I have a successful design if it's, if for me, all those things come together. And it is also something that I want to have a little bit an educative notion. For me, it's always important that my grandmother would understand it, even if she doesn't know in electronics and all of that stuff, coding, blah, blah, blah. And also my, our little nieces of like 6 years old, you know. For me, if a child can understand it and my grandmother, then it's a successful design, because it is this intuitive behavior that created them to be, okay, I should stay away from this, or I should go towards it. So that for me is, yeah, sort of the interaction design factor in there.
Yeah, it's from everything that I've read or researched about like the designs that you create, it's always that you you know, you're working with a company, or you're identifying a problem or some way that people are limited, and then you're working to design something to help to express yourself better. So like I think the three projects that I mostly like did deep dives on were the spider dress, where you were saying like if people are shy or people are not getting the right idea, it will like flare out, and it'll really make it very obvious that you're inside of this person's personal space. And then the smoke dress, which has to do with how shy people are feeling, and like how like opaque or concealed they want to be almost. And then the last one was the horn for development, like researching kids, and I think it was like ADD, ADHD.
I think you see them here.
Yeah, I can see them in the background.
But unicorn,
yeah, but it seems like a lot of the designs that you create are problem and solution oriented almost. It's
correct, yeah. And it also has to do with some pretty clear like output kind of thing, and where the input would be either environmental or the body, and the output would be like, yeah, whatever that can be. That's a little bit more fluctuating, sort of. So I use a lot of inputs would be sensing the surroundings or sensing the body. So I do what you say, EEG, for example, brain signals with Agent Unicorn, and the latest Pangolin BCI dress with 1024 channels, where the Agent Unicorn has 8 channels. I do a lot with HRV, heart rate, respiration, like EMG muscle contractions, and I'm trying to also see how it can conform. And also in a few of my projects, it has to do with stress, you know, like researching stress as well from both the surroundings as also the body, for example. So that's, I think you can do like really interesting things with body sensors, but especially the combination between the body sensors and the environmental sensors, or the combination between brain sensors and the heart, you know, and all these almost like, yeah, sort of module kind of ways of looking at that.
Yeah, I'm betting that you're waiting until you can get an IV in one of your dress designs and you can measure your cortisol levels.
I know. Right? Oh, that's going to be interesting. Yeah, all the chemistry that we have. Yeah.
Yeah. So I just wanted to like help field that question relating to like what your designs are hoping to achieve and things along that line.
Mhm.
If we could talk more about like back to more focused on like how our company and you are relating.
Mhm.
I know that we first got into touch with your spider dress, and I think that you sent me an email saying that it wasn't actually in the dress. You made like tiny little spider figurines that ran around with it, which I think is super cool. And I think that we've also sent you like our new. I'm looking at Andrew right now. This might be cut.
Oh,
Can I
no,
talk about this?
yeah, no, that's fine.
Okay, fantastic.
Yeah.
We sent you our new Dynamixels, the small micro servos. I think that you had like a very positive reaction to them. So I was curious about like what you thought of those servos and like how they might help you with your designs.
Yeah, sure. Yeah, how I know you guys was again like through Mark, of course. We spoke about that. And I've been using the XL 320. So these guys multiple times in we used them. I was researching them for the spider dress at that time. They were a little bit too big for the knuckles that I was forming them in the end. I used different servos, non-smart servos like hobby servos, but we did ended up using them for the spider bots that we created a little bit for like the maker fair. So they were like dancing, and that was together with Matt at Intel. He was creating these spider bots there. So we had them embedded in there and connected to the Intel Edison. And then a project from, I used them in a project for a home automation company, Somfy, in 2013, in 2015. I used them for lamps, also for the same company. I don't even know that you know that. I will send you all these projects.
Yeah, I don't think I've ever seen that.
I've never heard of that. That's so cool.
Yeah, they were like lamps, and the dress was moving out, and when it heard music, it started to dance. The dress and also the lamps were going open and close. So it was a cool project, and that also has the XL 320s in there. And actually, yeah, I should keep you guys updated more. And then last year I did a project with Cirque du Soleil, and it's called a tentacle dress, which is a dress which works on facial recognition, and it was scanning people's faces. And when you smile to the dress, it started to make a dance because it had like these tentacles on the shoulders. And those were also I created them using like interlinked 320s. I think there were like 3 each tentacle or something. So that was kind of a fun research kind of thing that we did for Cirque du Soleil. It was for their pre-show experience. So that was kind of cool. So yeah, now I got the new ones, which are these, and I'm super happy because I'm always emailing you guys like, hey, what kind of small units do you have, and what is coming up. So I was really happy that I got your email if I wanted to look at these. So these I love your packaging, first of all. And definitely I'm going to use these in a project that I'm talking about now with a client. I myself, I love the form factor. They are a little bit tinier than the XL like 320s. The housing is nicer from the design factor. And the little the turning wheels also like a little bit smaller. So I'm super happy to work with these in the next project. I think we haven't really decided exactly what it's going to do, but I'm trying to connect as many as I can in this design. I don't know exactly about the weight of the thing that it turns out in the end, and all of that stuff, but I will keep you guys updated on that.
Absolutely.
I think our protocol allows you to connect 54 of them together, 255 maybe.
And I'm kind of good. Yeah.
I think 253 just because of reserved ID numbers, but that's still a huge number.
What control board? Sorry, you might edit this out, but what control board? You got a new control board for the servo, or are you still using the CM? Not 530.
The CM board.
It'd be the OpenCM 904, OpenCR1, but I think she's using Intel-based controls because she's using a lot of facial recognition and learning algorithms, it sounds like.
Last one we used, we used it over Teensy to a Raspberry Pi because my main system was OpenCV, so it was actually a double connect sort of. But yeah, we were using OpenCV for the facial recognition, which was going to a Raspberry Pi Zero W, which was connected to a Teensy. So in this case, but I need to get a few more of your CM OpenCM boards for this thing, because otherwise it becomes a Frankenstein.
I mean, it's always just convenient to have a couple, but you know, I know a lot of our users are also really honestly, the Teensy boards are also really popular among a lot of people I talk to. So I was curious, do you have a like particular model of Teensy that you prefer?
It depends for like, you have different boards for like, if I connect audio versus other things, but like the simpler ones, Paul just recently made a new one, I think it's the 4.0, 4.2. I have like a lot of like 3.2 still laying around here. So mostly if I'm doing prototyping, I'm using them up before I'm using the others. I'm using a lot of Teensy 3.5, 3.6 in the past. And now I also have the 4.0 for 4.2. So it's it depends on how much of things I'm using for that. In the Cirque du Soleil one, I just needed to have like a few connections because I was serialing them. So I just used the 3.2 and then to the Raspberry Pi Zero W sort of.
Okay.
So
yeah, I'm just really happy to hear that you know, you had just such a positive impression of the XL330 models. So, you know, those are the newer upgraded ones that we'd sent you. So that was something that we've been working on for quite a while. So right now, just as an update, we're anticipating to release them in early 2021. So just with, just as a, you know, a bit of a small update. And then obviously, I'm sure there'll be plenty of updates and newsletters from ROBOTIS as the release date is finalized.
Yeah, cannot wait. I always say like, the more like, sort of miniature you go and all of that stuff, that's always great, especially for like stuff that I do on the body. So I'm always super, embracing that. That's all super cool when that happens. I did like always the 320 because you always see the gears. If I work with workshops with children, like they always love this because you see everything in there. But I love this one because it has more the industrial vibe sort of. If I work with clients or automotive clients and all of that stuff, they always rather see sort of more this. And then the makers and the children always like this kind of vibe sort of. But I love the style. I love the more sort of industrial look, like some of the bigger motors that you guys have.
Yeah, so it's interesting. Whenever I'm whenever I'm looking at projects that use servos, I have to look really, really hard to find Dynamixels because they're so like, they're very subtle servos. They just disappear into designs, and it's frustrating for me because I'll be like, is that an AX12A? Is that you know, a normal servo? And I say, should I reach out to these people, or should I just be like, no, there's no way. I think it's funny how like almost invisible servos are when they're like pretty much omnipresent in a lot of these kinds of robotic designs or industrial use.
Yeah, industrial use, I think more people like would hide them. But if you talk to like roboticists and all of that stuff, for me, I always like to show like part of it. Like the tentacle dress is kind of cool because you see the XL320s, you see the lights coming through and the sort of semi-transparent kind of look of it. So I really like that, part of that. And other times you want to like more hide it, of course. I know Mark, he's doing a lot with showing the servos as well, you know, in his designs. So I kind of, I always love to show the hardware components and then all of that. I think it's just a cool, and maybe it's like geeky. It's a very like, kind of nerdy thing to show it, but it's for me educative, you know, even if a child looks at it, it's like, oh, wow, these are servos instead of that they're staring to a part of 3D prints, you know? So I think, the educative notion sometimes is really cool if designers do use it as the bare, motor or LED or whatever it is sort of.
I mean, it definitely is like a choice, like a form of expression. I don't, because
Mm.
I'm a very big nerd. Like I'm into like a lot of things, but I go out in a button down dress shirt and slacks every day. No one can tell that like I work on rockets or I work on like
Yeah.
battle bots. It's there's no form of expression through my clothing that shows that I'm pretty active in like the maker community or as like a machinist. So it's kind of like one of those things where, that's a large portion of my life that is not being expressed via my
Mhm.
clothing,
Yeah.
which is sad. Yeah.
We should work on that. Having our parts come out.
Yeah. Have a robotic arm that comes out.
Yeah.
Yeah, I
There's
love
a-
it.
Modern parrot on
More
your
for that.
Have you seen in Japan? There's a few people that they add 3 and 4 arms.
Yeah, I saw that.
Yeah.
It's based on a movie, I think, the sort of the Doctor Octopus kind of stuff and all. Yeah, that's cool. I love it when it has like a utilization as well, when people use robot arms to actually do something, yeah, that's always yeah.
I think my next trip is actually to the Netherlands. That's the next place like off of my checklist.
Oh,
I've never been.
Your last name is from the Netherlands, Vlietstra. And you have
Yeah.
Vliet and Vlietstra friends. Yeah, if you go there, definitely go biking. We have a really good biking culture, and yeah, all the cities are pretty cute. But you should go in the summer. Don't go in the winter because it's just dirty and nasty and cold and all that stuff. So don't go there in the winter. It's the reason I left there.
Yeah, I think that's like one of the things on my bucket list that I need to check off sometime. But with the world how it is, it's a little difficult to travel.
Yeah, I know, right? Yeah, I'm actually from Beemster, and Beemster is the first proclaimed land in the 14th century. The Dutch started to proclaim their lands, claim their lands back, sort of. And Beemster was the first place that they did that. So I come from the village. There's like 9,000 people. And so there's a lot of like water engineers and a lot of engineering there comes all from that place. But it's in the whole touristic city. So you have Volendam and Zaanstad and Zaandam and all that whole touristic Holland. I'm from Holland. It's all in that area, but it's pretty cute. But in the summer, not in the winter.
That's cool. I didn't think
Wind
about
mills,
like the
wind
fact.
mills are amazing. Like I used to go there and see just the whole mechanism. It uses multiple purpose. Like it pulls up the water, it crushes the like sort of the tarwa and the mustard seeds and all of that stuff. So the mechanisms of the windmills are really interesting. So pumping up the water, but also using it for for making stuff.
Yeah, I didn't really think about like where from, because I asked you about where from the Netherlands you were from, and we talked about it over email, but I didn't think about the fact that like there were probably a lot of engineers like from where you were, as well as like windmills mechanics that probably played a big role on like a mechanically inclined childhood almost.
Yeah, I think that's. I was just doing an interview for another thing, and they asked me about if coming from the Netherlands did something to me. But the other thing is like that. First of all, like we have a lot of like technical stuff, and Philips, of course, is really big there. And the other thing is, I think like in the Netherlands, we don't have really a big diversion between boy and girl, so you can just easily be doing a boy job in the Netherlands, and it doesn't matter, so like the notion of gender is not really specified in the Netherlands. The girls are more boyish, and sometimes the boys are more girlish, almost, if you want to define it that way. So I guess it's easier to go into like a technical job and all of that stuff and have a technical interest than maybe in America, or like, I don't know exactly, like different countries sort of. I think a lot of girls that came out of the Netherlands like do have like very more technical jobs than because there was a big allowance for that almost. It's pretty interesting country.
As another technical question, I have like a couple more questions.
Yeah.
As a technical question, so do you program in the Arduino environment? Do you use C or Python, or how do you do your programming for your like the Edison or some of the OpenCM? You using just the Arduino IDEs? That's what you use?
Yeah, if I'm using Arduino, I'm using Arduino, Teensy Arduino over Arduino, sort of. Some projects have been collaborations, have been in C, but I'm not really high on C because I'm more like hardware related. Most of the projects, the current projects, are Python. Python in, especially because when I started to have to deal with like Raspberry Pis, like Raspberry Pi 1 and 2, like 8 years back or 10 years back, when I started to use them for more video related stuff, because I could not use Arduino for that. Of course, that was Python. Intel Edison was also Python. So yeah, that's it's mainly if you're using like your make your own boards. I have some tutorials like cat ears and all of that stuff using ATtinies. So it always depends on basically the boards that I'm using. If I'm doing simple things, I would just use Arduino for prototyping, all of that stuff. But mostly now it goes over in the end into Python because of all kinds of reasons. Because there's video, because there's facial recognition. Sensors can still go easily over Arduino, but it really depends on what it is. But definitely, if you have connected to video, if you have connections to all of that stuff, definitely then it goes into Python.
Yeah. So if any kids are watching, I hear this all the time. Get a Raspberry Pi, learn Scratch, and once you get Scratch, understand Scratch, then jump into Python, because it seems like everybody is using Python for vision processing, for robotics, and all kinds of stuff now. So yeah, cool.
Yeah,
and of course, like open source things, Arduino.cc. If you're like getting started with electronics, if you're starting with 3D modeling, there's a guy in the Netherlands. He created Blender. Blender is an open source, sort of 3D modeling tool.
Yeah,
Which got a lot of more attention now. A lot of more architects are going on it recently. It came more from a sculpting background, but it's got more robust and better and better. So that's a free and open source software, because 3D software can be expensive, especially like Autodesk Maya, Rhino, like all of that stuff sort of. But Blender is kind of a cool thing, and there's a lot of like cool tutorials online that you can find as well. If you're interested in EEG, the OpenBCI community is really interesting, an open source brain-computer interface community. If you're interested in like brain signals and all of that stuff. So I guess there's a lot of like open source stuff available, Hackster.io, Instructables.com, and all of that stuff. So yeah, check those things out as well if you're wanting to get into electronics.
I think that we're getting to like a point, like a natural conclusion point of the show. So if you have anything that you'd like to plug or talk about,
and if you have any questions, you can reach me on Instagram, Facebook. If you want to get started with things you don't know how, or you want to start to get into robotics, you don't know whatever, like just send me an email. Is anoukWipprecht@gmail.com, or through my social media, and I hope to respond to you.
All right, Michael, do you have anything that you would like to plug?
Just I'm also out on social media, so if you want to get in touch with me, talk robotics. I love talking about robotics and, of course, 3D printing and maker movements, stuff like that. Especially kids, STEM. Actually, STREAM. That's my new buzzword: science, technology, robotics, engineering, art, and math.
All right. And if you want to hear more from us at Robotis, you can leave a comment in the video down below. Our email is cs@robotis. You can follow us on Facebook, Instagram, and TikTok under the name Robotis America. And I hope that you all have a fantastic day.